What is misalignment? Misalignment means you have too much offset and angularity between two shaft center lines of rotation. What can cause machine misalignment? Improper installation, foundation issues, failing to account for thermal growth, pipe stress, load stresses, soft foot or machine frame distortion. The effects of misalignment are high vibration, premature equipment failures, increased power consumption, and reduced production. There's no excuse to let misalignment cost you money. Protect your machines and minimize costly downtime with precision laser shaft alignment. Shaft alignment know-how. The basics. Misalignment of the shafts causes vibration in both machines. This will damage the bearings, seals, coupling, or other machine components. Good shaft alignment allows machines to run more efficiently, reducing power consumption while increasing output. Let's look at how it's done. Very common rotating machines in industry are pump and motor sets. When a motor runs, the shaft rotates and transmits power through the coupling to the pump. Because alignment is so important, tolerances were developed to define the most misalignment you can have and still be okay. We will explain about these tolerances in a future video. If this was a 3600 RPM motor, these would be the tolerances. Forget for a second that we are aligning two machine shafts. Instead, imagine two simple lines that represent the shafts. The goal of an alignment technician is to adjust these two lines to be collinear. Collinear means that two lines are positioned as if they were one single line. In the real world, we aim to align the machines as collinear as possible within tolerance, at the coupling or point of power transmission. Typically, the machines will be misaligned in two ways and in two dimensions. Let's visualize this. Vertical and horizontal. Both vertical and horizontal directions each have a combination of offset and angular misalignment. To measure, we rotate the shafts to find the relative positions between the two center lines of rotation. Once we know the misalignment, we can correct it by adjusting the movable machine vertically and moving it side to side in the horizontal plane. If we get the two rotational center lines to be nearly within tolerances in these two directions or planes, then they will be nearly collinear and therefore properly aligned. The process of precision alignment can be broken down into three simple steps. First, measuring and inputting the machine dimensions. Second, measuring the misalignment between the shaft center lines of rotation. And finally, calculating the necessary corrections and aligning the machine to be moved. Shaft alignment know-how. The 5-step procedure. When we perform a shaft alignment on any machine, we should all follow a set procedure. Following, we present Ludeca's recommendation for a simple and effective procedure for doing shaft alignment. First, we perform the pre-alignment checks, safety procedures, lockout and tagout of the machines, visual inspection of the foundation, grout, and base plate, cleanup, remove rust, scale, paint, and dirt from the bottom and around the feet. Replace damaged shim packs with new, corrosion and crush-resistant shims, filling obvious gaps under the feet. Secondly, we perform a rough alignment and rough soft foot correction simultaneously. The goal is to eliminate coupling strain and ensure that the machine is alignable. Now it is time for step 3. The first alignment check with the laser system to ensure measurement repeatability and that the misalignment is less than 15 thousandths at the coupling. In the fourth step, we diagnose and correct soft foot with the assistance of the laser system. Aim to have all soft foot readings within 0.02. Finally, in the fifth and last step, we measure the alignment, make corrections, and achieve the final alignment to any required targets within tolerances. Shaft alignment know-how. Installation. Many equipment failures occur during what is called the infant mortality period. In other words, soon after machines are first put in service and are typically due to poor installation. The foundation must be able to withstand the mass of the equipment and any operational load stresses and vibration that the machines will generate. Once we ensure that it is well prepared, flat and level, we can mount the base plate upon it and properly bolted or grouted to the foundation and ensure that it too is flat and level. With the base plate in place, the rotating equipment should be centered horizontally upon it and an equal amount of shims placed under each foot, while keeping the required axial gap. Installing jack bolts is also recommended to facilitate horizontal movement of the machines. Finally, all anchor bolts on the machines should be tightened to the proper torque. Likewise, all pipe fitting should be completed without imposing any stress on the machines. When machinery is properly installed and given reasonable maintenance, the asset's operating life should meet or exceed its life expectancy. A precision alignment of the machines to proper tolerances is required before releasing the asset to operations and be put in service. Soft foot means machine frame distortion that occurs as the machine's hold-down bolts are loosened or tightened. Distortion of the machine frame leads to misalignment at the coupling, internal misalignment of the bearings, increased radial load on the bearings, and a deflected shaft. Therefore, a soft foot condition creates two inflection points on the shaft, which produce vibration as the shaft rotates. The shaft doesn't like to be deflected, so it tries to straighten itself out. When it does, it pushes on the bearing, causing out of roundness. These forces on the bearings cause them to wear unevenly and fail prematurely. So fixing a soft foot condition will always increase the life of the bearings and the efficiency of the machine. There can be many different causes for machine frame distortion, which are diagnosed as different types of soft foot for the purpose of correcting this distortion. All of these conditions cause the machine frame to distort. To determine which type of soft foot a machine has, we can use laser alignment systems to measure the amount of movement a soft foot produces at the shaft centerline when loosening or tightening a foot. The combination of movement the machine exhibits upon tightening or loosening each of the anchor bolts helps us to diagnose the problem and therefore find the correct solution. Shaft alignment know-how: bolt-bound or base-bound. A common problem we encounter when doing shaft alignment is to become bolt-bound or base-bound. This is defined as a condition that prevents a machine adjustment from being accomplished because of insufficient clearance. Common solutions to being bolt-bound are: increase the bolt hole size in the machine foot, reduce the shank diameter of the anchor bolt, drill and tap a new hole in the base, or make an optimal move, which is usually the best option because it saves time and does not require working on the structural components of the machine or its base. An optimal move means making a small adjustment on the stationary machine to eliminate the need for the impossible move on the machine that originally became bolt-bound. We simply use the laser alignment system to show us the smallest correction. The same applies for the base-bound condition. Becoming bolt or base-bound can generally be prevented with proper initial machine installation and centering the stationary machine on the base plate to ensure that the movable machine will be alignable to it. Shaft alignment know-how: pipe stress. Often during pump installations, pipe and pump flanges are not in alignment. When mated together, the pipe stress pulls on the pump flange. This forces the frame of the pump to distort vertically and/or horizontally. The resulting deflection of the pump casing results in internal misalignment of the bearings, inducing vibration and premature failures. Sometimes it is thermal growth that causes pipe stress and the resulting strain, changing the alignment at the coupling. It is important to check for pipe stress during pipe installation. A good laser alignment system can help you do this. Eliminating pipe stress will greatly improve the reliability of your machines. Shaft alignment know-how. Thermal growth, positional change. Not accounting for positional change in rotating machinery is a big reason why maintenance departments stay reactive instead of proactive. When rotating equipment runs, it heats up and undergoes positional changes. This can occur due to thermal growth, dynamic load shifts, pipe stress, and other factors. Therefore, it may be desirable to deliberately misalign the two shaft center lines when cold and stopped by the correct amount to compensate for these anticipated changes. To do this, we need to determine the amount of movement that occurs between the two shaft center lines. The best of several ways to determine this information is to monitor the movement. We track the positional change of the machines continuously from the cold to the hot condition, or vice versa. Once you know how the machines move with respect to each other, it is very important to input the target values in your laser shaft alignment system if it features this capability. It will then calculate where machines should be positioned when cold and stopped to get correct alignment when they are. Shaft alignment know-how. Repeatability. We have all heard the old carpenters saying, measure twice, cut once. When we start a shaft alignment measurement, we take two sets of readings with the same start and stop positions, following the natural rotation of the machine. This way, we make sure that the needed alignment corrections are precise. We call this repeatability. It means achieving the identical measurement results in the same way, on the same machine, under the same conditions. A measurement table helps to keep track of these measurements. Once rough alignment has been performed, the results should be no more than 1 or 2 thousandths apart, which is not the case in this example. It makes no sense to proceed with the alignment until and unless repeatable readings have been achieved. If repeatability is poor, there may be several root causes to consider, such as loose components, worn bearings, loose anchor bolts, and vibration from nearby machines, among other causes. Once the culprit is found and addressed, take 2 new sets of readings to establish repeatability. Now that repeatability has been achieved as shown in this table, proceed with the alignment. Confidently perform the alignment corrections as called for by shimming your machine vertically and moving it horizontally.